All right, our first learning outcome is just whether we can determine if a sequence is arithmetic, geometric, or neither. And so I think we're probably feeling good about this by now. For that first sequence, if I look, I could see that as those terms are decreasing, each term is 1/2 the previous term. So you might see that as division by 2 or multiplication by 1/2. And we said if we notice a division or multiplication pattern, that we in fact have a geometric sequence. So I'm going to put a G there for geometric. All right, the next sequence, let's see. I might, off the top of my head, I don't think I know an integer where 3 times that integer is 5, but I'm not sure yet. I'm going to check first to see if it's arithmetic. So I know if I'm thinking with addition, like 3 plus 2 is 5, but 5 plus 3 is 8. And as the pattern continues, I see that I'm adding 4 and then 5. So I know that that sequence is not arithmetic because there's not a constant or common difference between terms. Okay, so next I might check to see if it's geometric. And remember how we check for that common ratio. I want to divide, well, I don't really know what 17 divided by 12 is. I bet my calculator does. I want to divide a term by its previous term. So 17 divided by 12, 12 divided by 8, 8 divided by 5, 5 divided by 3. I want to divide those numbers and see if I get the same number. If I do, I call that my common ratio, and that would mean I have another geometric sequence. All right, so I'm going to try that real fast in my calculator. Let's see, so 17, it's not being very friendly with me right now. 17 divided by 12, it looks like that is 1.416, or maybe that 6 is repeating. 12 divided by 8. Oh, now wait a minute. That's 1.5. So you know what? I don't think I really even have to keep going. I can check them. But as I keep dividing those numbers, I get different ratios. So all that to say, there's not a common ratio. There's not a common difference. So that is neither arithmetic nor geometric. All right, last sequence. Oh, this one looks nice. I know that 8 plus 3 is 11. And if I don't know that, and I'm looking for that, what is hopefully a common difference, I want to subtract, right? That's why we call it a difference. It's a difference from one term to the previous term. So 11 minus 8 is 3. I could subtract backwards or I could add forwards. So I notice that 11 plus 3 is 14, which when I add 3 to that, I get 17. And subsequently, when I add 3 to that, I get 20. So I'm going to say this is arithmetic with a common difference or constant difference of 3. All right, so we kind of just talked about how to do this next thing. Oh, and you know what? I'm feeling very confident about this right now. So I'm going to indicate on this continuum that I feel good about this. And this is a skill that I probably don't need additional practice with. But if you are feeling, I don't know, somewhere in the middle, or especially if you're feeling over here that you do not yet feel confident about this, let your teacher know or get some help with in the tutoring center with either a peer tutor or in the math resource center with a teacher tutor. And if you're not sure how to do that, see your teacher, which may be me, depending on who's watching this video, for help. All right, in item 2, I can express a common or constant difference. In this context, we use those words interchangeably. So a common or constant difference as the number that I add to get the next term of an arithmetic sequence. So I'm finding the common difference from each sequence. Remember, we said we call it a difference because I'm subtracting, I'm basically subtracting in the reverse order. So if you look at this pattern in 2A and you notice hey, I think that sequence is decreasing by 5. You are correct. And we would say the common difference is -5 because again, the common difference is the number that gets added. So 25 minus 5 is 20, but I could also say that 25 plus that negative 5 yields 20. Remember, when I add a positive integer and a negative integer, their sum is going to be less than that positive integer. Wow, I really said that in a weird way. Their sum is going to be the difference between those two numbers, except it will take the sign of the first number. So we could say the difference between the absolute values of those two numbers with the sign of the number with the greatest absolute value. And if what I said just now confused you, then honestly, don't worry about it. We'll talk about absolute value later this year. All right, so also we said we call this a common difference because I can always figure this out by subtracting in the opposite order. So like 5 minus 10 is negative 5. If I subtract these terms, 10 minus 15 is negative 5. So it's like instead of thinking additively, I'm working backwards to think, well, about subtraction. Subtractively, I don't know if there's a word for that. Okay, 2b, similar sequence. In fact, I think I maybe just copy and pasted the one from 1C. I sure did. So again, our common difference here is 3. I bet you remember that from a few minutes ago. And again, I could either think about what I'm adding by or work backwards and subtract. 20 minus 17 is 3. 17 minus 4 is 3. So our common difference is positive 3. All right, I'm feeling very confident about this right now. All right, number 3, I can express a common ratio as the number by which I multiply, the number I multiply by to get to the next term of a geometric sequence. All right, let's see how confident we feel about this. So in 3a, I notice that those numbers are decreasing. And I kind of already know this is definitely a geometric sequence because I was kind of told that in the prompt, and I'm asked to find the common ratio. So I might notice, like I don't know off the top of my head what to multiply by to go from 108 to 36, but I might be able to reason here with some smaller numbers, say 12 and 4. And I think a lot of students are going to think of this as a division pattern. And while you are not wrong about noticing that we can see a division pattern, when we express the common ratio, it's really important that we express it as what we are multiplying by. And in class, we talked about using the reciprocal of the thing we're dividing by. So, as I'm looking at this, one way is if I just work backwards and divide. I could divide any term by its previous term to get the common ratio. So 30, oops, I almost wrote 180. Been teaching geometry for too many years. All right, 36 divided by 108. All right, I could do that division in my calculator if I don't know what that is. I could also simplify that fraction and, sorry, sometimes this on-screen calculator likes to pretend it doesn't work. I'm going to show you real fast. This is something we can do in our graphing calculators. If I do 36 divided by 108, I get 0.3 repeating, and I recognize that as the fraction 1/3. There's a couple ways we could also get the calculator to help us, and we also should practice like simplifying this. But just for today, just to make sure we can see that that's 1/3, I could do a few things. I could go to the button under the green alpha button that says math. And that very first option where I see like an arrow and then frac, that stands for fraction. And that's going to take that number I just got and rewrite it as a fraction. We call it a common fraction, or you might think of it as a simplified fraction. So 36 over 108 is 1/3. Alternately, though, with smaller numbers, we could probably do that ourselves. So let's see, 12 divided by 36 is also 1/3. The way that we think about this a lot is dividing the top and the bottom by their greatest common factor. So I know 36 and 12 are both divisible by 6. So that's going to yield to over. Oh, I could have picked a bigger factor. I could have picked 12. Oh my goodness. I'm so sorry. I'm so tired. But you know what? It's okay to start with a factor that's not your greatest common factor. Because when I do this, I notice, oh, hey, both of these numbers are still divisible by the number 2. So when I divide 2 by 2, I get 1. When I divide 6 by 2, I get 3. So again, those are equal to 1/3. All right, and then 4 divided by 12 is also 1/3. And 4/3 divided by 4, we call that a complex fraction. When you have a fraction in a fraction, that will also reduce to 1/3. And we can come back to those later. If you were to express your common ratio as a decimal, that's not incorrect. 1/3 is 0.3 repeating, or we would have to round that. But if we're using this in an equation and we're going to generate other terms in our sequence, we really don't want to use a fraction or a decimal that we have to round if we can avoid it, because we will be off by a little bit. All right, looking at this next sequence. Let's see, I'm looking for my common ratio again. So I'm just gonna, I noticed that this pattern's alternating from positive to negative. Let's see what that means. All right, 80 divided by negative 40. Let's see, 80 divided by 40 is 2. A positive divided by a negative has a negative quotient, so a negative 2. Negative 40 divided by 20 is also negative 2. So again, we could keep going. If this sequence is truly geometric, they should all, and it is, unless I made a mistake, they should all have that common ratio of negative 2. All right, lastly, oh man, I got a sequence with a bunch of fractions in it. That seems really fun. Yay! I'm joking. I actually love fractions, but I'm told that's an unpopular opinion. All right, if I want to find my common ratio, 27 over 2, or 27 halves, and then turning that into a 9 with multiplication. If I just feel like that's going to break my brain, I could just use a calculator. And again, if I already know for a fact that my sequence is geometric, and we do not know that here because I told you up here that it would be. We don't always know that, but if I know that for a fact, I could just pick any two terms, divide one term by the previous term. So like I could divide 6 by 9, or I could divide 4 by 6. It seems easiest to use those integers. Again, I showed you how the calculator could simplify that for you, or we could divide these each by their greatest common factor. So the GCF of 6 and 9 is 3. So I would get 6 divided by 3 is 2. 9 divided by 3 is 3. So that yields 2/3. 4 over 6, their GCF is 2. When I divide both of those numbers by 2, I get 2 over 3, 2/3. So that's in fact my common ratio.